Hey, ladies and gentlemen, today solving systems of linear equations by substitution. We're going to solve 3 problems today using substitution. Okay? Here we go. So, rather than graphing, another method is to actually use substitution. Okay? So, just so that we're aware and we try to tie all this together, you could graph these and come up with the same answer. Okay? We're going to use substitution. In order to use substitution, there's some steps you can do up here on the exploration. So we're actually going to work through this exploration together. Okay? First thing we're going to do, solve for x or solve for y. Okay, when I'm looking at this and I'm saying, okay, which one do I want to solve for? Well, the first thing I have to do is take one of my equations. So if I ignore one of them, so I'm going to ignore the bottom one for a minute and just look at the top one. I want to get x or y by itself on one side. So you guys choose which one. X, raise your hand. Y, raise your hand. Okay, we're going to get y by itself. So everyone get y by itself on that equation. All right. Y equals negative x minus 7. Okay, we subtract x on both sides. Okay, so if y equals negative x minus 7, I'm just going to rewrite that right above it here. Now done with this. Okay. Substitution says I can take and once I get one of my variables by itself, I have 2 different names for y. I could take the thing that y equals and put it in the other equation where I see the value of y. And so the way I show that is I just circle both parts. Okay. That's using substitution. And so what happens when you substitute that in, you're left with a resulting equation. Notice here I have my negative 5x, it hasn't changed. I have a plus, it hasn't changed. The thing that changed was y is no longer called y, it's called negative x minus 7. And then the equals 5 stays the same. And the benefit of doing that is now I have a single equation where I have one variable. Okay, do the parentheses matter? Nope, you're not distributing anything into them, so we can just rewrite it. Notice the negative and the positive just becomes a minus. And now we just simplify and solve for x. This is negative 6x minus 7. That's equal to 5. I then add 7 to both sides. Negative 6x equals 12. I then divide by negative 6 to get x equals negative 2. All right. So here's the deal. You now know x. Have you solved the system? No. All of our answers yesterday had a coordinate answer. We had an xy value. Well, right now we only have an x. We need the y. Okay, well, we know y equals negative x minus 7, so if I put what x is in for x here, please note that you're actually only plugging in for x. The negative on the outside and the negative 7 on the outside of x, those stay. The only thing you're putting in is you're replacing the x with a negative 2. So negative 2 is 2. Thank you. Negative 2 is 2. 2 plus 7, or 2 minus 7 is negative 5. So y equals negative 5. We now have our coordinate 2, or negative 2, negative 5. If you were to graph those 2 lines, tell your neighbor what this would mean.
That would be where they intersect.
Good, as that is where they intersect. All right. Okay, any questions? All right, so the goal is to figure out which variable to get a loan. So when you're looking at letter B, I want you to figure out which equation you should work with to get a variable alone. It doesn't matter which equation you use, it's just a lot of times there's, like in this one, there's definitely an easier equation to get a variable alone in. Which one do you want to use? Yeah, you want to get, look, x doesn't have a number in front of it, doesn't have a coefficient. So probably get x alone. How do you get x alone? Add 6y to this side over here. By doing that, that gives you x by itself, and you're left with 6y minus 11. So you know x equals 6y minus 11. Okay, go ahead and draw your line and connect it to where that's going to get plugged in. Huh? Because x was easier to get alone. Yep. Okay, so I'm going to draw my line and plug it in right there. We good there? Resulting equation. 3. The x is no longer x. It's 6 y minus 11. We have the plus 2y. And they equal 7. Go through and solve. Distributive properties, so stuff we've done earlier in the year. How many y's? 20 y's. What's the next step? Add 33. 20y equals 40. And now, divide by 20, y equals 2. If y is 2, plug that back in up here to our 6y minus 11. So that's x equals 6 times 2 minus 11. What is that? X equals 12 minus 1, or x equals 12 minus 11, or x equals 1. So the coordinate is 1, 2. Means our graph crosses at 1, 2. All right, we're not going to do letter C together, but I want you to tell your neighbor which equation you get the variable alone in, and what variable would it be. Okay, top or bottom? Top equation, what variable you getting alone? The y. How come? No number in front of it, okay? All right, that is substitution. What was the first method we learned? Graphing. Second is substitution. That'll be today and tomorrow.